Hello, Morgan. I forgot to bring my camera today, of all days, and I'm just going to run over with you at home what we went over in class. So I hope you have a time to watch it. And this is a pay-per-view, so you don't get the board even set up. So the first thing we did today, and I hope you're feeling okay, if you stayed home for a toe day, or was it a mental health day, or something in between? Whatever, I hope you're doing better and ready to tackle new things. The first thing, however, is not new, and we have just a discussion on the homework. So I'll show you what we talked about. The first one we were asked to do was to find the volume of a solid that had a base that was a circle. X squared plus y squared equals, wasn't it 2? So, no, 4. It was 4. X squared plus y squared equaled 4. And we were marching across that base with equilateral triangles. So I drew in a little bitty one here and then a bigger one. But the one I picked to study is this one right here. So imagine an infinite number of these equilateral triangles forming a solid across this circular base. So since they're triangles, we know that we're going to need the volume. So we'll start with the area of a triangle is 1/2 base times height. And then the thickness of each one is a dx. So we're going to look at that. And I pulled the 1/2 across. And since this was a circle radius 4, it went from radius 2. So it's x squared plus y squared equals 4. So that's radius 2. So it went from -2 to 2, but I wrote in those limits of integration and base height dx. And then down this step, I decided to keep -2 to 2, and the base, we did this one on the board in form of square. We saw from here to here was the value y, and since we have to go from here to here, if this is y, then this is 2y. So our b became 2y, and now we're looking at the height. And we had discussed the height earlier in our comp book about equilateral triangles. And if this is base b, and this is base b, and we cut this in half, and only look at this side, this becomes 1/2 b. And what would this height be? And it turned out the one that we studied in our comp book was a little bit different than this one. If you recall, we called this, this is the one we studied in our comp book. And when we did the Pythagorean theorem, we got square root of 3 over 2 times b here. So these were all proportional. But the one that we're doing, this was 1b, but see, our base is 2b. So this whole thing in ours is 2y, we'll call it. And then this would be 1y. And this is 2y. And so see how these are lining up? They're all doubled. So this would just be square root of 3y. So I think when I set this up yesterday for you, when I got to the height, I said square root of 3 over 2 times y. But it should have been just square root of 3. So if you did it with the square root of 3 over 2, all you have to do is take your answer and multiply it by 2, and you should get my answer. All right, so sorry about that. And I also prefer to work, since this is a completely symmetrical figure, I'm going to work from 0 to 2. It's easier to work with those limits of integration, and I will double this. So I pulled the 2 out. There's already a 1/2. They cancel. So I still have a 2 in here, which can come across the integral sign. So we still have 1, 2 there. And we're working in x, so I have to write this y in terms of x. So that is square root of 4 minus x squared, which isn't too bad in this problem. And that square root of 3 can come across as well in front of the integral sign. And then we have the y again, 4 minus the square root of 2. And these, when you multiply those together, the radical disappears. And I have 2 square roots of 3 on the outside, and I have to integrate 4 minus x squared on the inside from 0 to 2. So I'll drop you off there. You can finish it or check yours against mine. And we came up with 18.5 or 32 square roots of 3 over 3 if you kept the fractions and radicals. All right, so let me know when you wrestle that one to the ground and get that one, and I'll give you credit for that. You can just show it to me. If it's in your comp book, that's fine. All right, the next one that we had was a arc length. I started with the formula. The problem was y equals ln of x plus 1 from 1 to 6. So I set up the integral from 1 to 6 of the square root of 1. The derivative of ln of x plus 1 is just 1 over x, which I have to double. So it turned out that that was not something we know how to integrate, so we just used the calculator and used the property. They have a integration mechanism in there, so if you need help with that, let me know. But I think everyone said they knew how to do that. So we came up with 5.38. So also show me your problem when it's complete. And you get that answer. Surface area followed, and we were wrapping ribbons around things and adding up an infinite number of those ribbons. And it turned out that the length of each ribbon was 2 pi r, and the width was our old friend, the arc length. So in this particular problem here, we kind of have a sketch of it. Here's y equals 1/3 x cubed from 0 to 3. It's wrapping around the x-axis. And here is my radius. And when I go back to put that in the formula, I have 2 pi r. So 2 pi, when I get to radius, I notice it's a y value on my picture. So that y value I'll just call y for right now, times the square root of 1. The derivative of 1/3 x cubed was x squared. And when I square that, I get x to the 4th. So I can't work in y, but y is the same as 1/3 x cubed, so I replace y with 1/3 x cubed. Now this looks like a bear, but it's really quite integratable. By use substitution, 1 plus x to the 4th, and du equals 4x to the 3rd. And let me move this 1/3 over the integral sign. So now, with the 1/3 out of there, I need a du in here of 4. So I sneak in a 4 and I adjust for it outside by a 1/4. So this integral becomes 2 over 12, and that is pi over 6 outside. And inside now, I'm going to have the square root of u du, and that is u to the 1/2, which is easy to integrate. So when I integrate u to the 1/2, I get u to the 3/2 times 2/3. And that goes, eventually we're going to integrate that between 0 and 3. And coming over here, pi over 6 times 2/3 becomes 2 over 18, which reduces to pi over 9. And we have, I'll go back to x land with 1 plus x to the 4th. For my u is raised to the 3/2, and that is what I will put in my 0 to 3. So when I do that, I'm going to get pi over 9 times, what is 3 raised to the 4? 81 plus 1 is 82 to the 3/2 minus, this time the 0 does not zero out, so I get a 1 to the 3/2, which is just the 1. So this, from here, I can leave it like that, or I can switch to a calculator and get 258.85, and those are square units for surface area. All right, so that one we kind of did all the way. So when you write that down, just show it to me or show me that you were able to get it before I did. All right, let's look at some new ideas for today on the next section. So I'm going to shut down this video. It's been about 10 minutes. And go ahead and put up the next one. So see you in a minute.